All right, so let's take a look at this problem. The directions have changed from the previous one. It says for each graph below, state the maximum and minimum values of the graph, where they will occur on the interval from 0 to 2 pi. And this time it looks like it's including both endpoints, 0 and 2 pi. I don't think students will have a very difficult time finding the value of the max and the min, but you might have a difficult time in finding location of where those max and mins occur. So let's do the easy part first. Let's find this max and min. Let's start with the center line, and I can see that we're not lifting the original parent function up or pushing it down because we're not adding or subtracting any value to that. So the new center line is still y equals 3. Excuse me, y equals 0, and the amplitude is 3. So 3 units above and 3 units below the center line are the max and min. So that's why I say I think that it will be pretty easy for you to recognize what the max and the min are. Now, for the location of these max and mins, and since they're wanting us to do it on 0 to 2 pi, we look and we see that the coefficient in front of x has changed, that 2, that my new period, the period for the original parent function, the sine of x, is 2 pi. But to find the period of this new graph, always take 2 pi divided by the coefficient in front of x, and it's shorter. Okay, so we're going to gain places. We're going to gain maximum points and minimum points. See, right now on this interval from 0 to 2 pi, we only see one maximum. On the interval from 0 to 2 pi, we only see one minimum. But on that same distance, 0 to 2 pi, if you now complete 2 cycles in that amount of time, because it's completing 1 cycle every pi units, we're going to gain 1 max and 1 min. So we'll have to have 2 locations for this maximum of 3 and 2 locations for this minimum of -3. All right, so let's figure out what they are. Let's take this expression 2x plus pi over 3, and if we replace that with pi over 2, then we know that we would be at a maximum value. So let's solve this equation for x. So if we have pi over 2 minus, I'm all tangled up here, pi over 2 minus pi over 3, get a common denominator of 6. So we've got 3 over 6 minus 2 pi over 6, and 3 minus 2, we just get pi over 6. And divide by 2, and we get pi over 12. So I claim that the first location is at pi over 12. Now, I also know that the distances between maximums is the length of the cycle. Okay, from here to the next maximum up here, this distance that it takes to get from there to its next maximum on the original parent function is 2 pi, because that's the period. Well, now the period is pi, so if I'm at pi over 12, I know the next time that it reaches its maximum is pi units away from that, is 1 period away from that. So I know that the next one is going to be at 13 pi over 12, because I just add pi to that. 1 pi over 12 plus pi is 13 pi over 12. So now if you don't see that, you can still do this idea of replacing this expression with the next time that it's at its max, which is at 5 pi over 2. Because 5 over 2, you're past the 2 pi. So if we solve this for x, we're going to get 13 pi over 12. If we get a common denominator of 6, we've got to multiply this by 3 over 3. So we've got 15 minus 2, which is 13. And if you divide by 2, oh, Bob Knight's going to be on the Bob and Tom show this morning. All right, 13 pi over 12, which is exactly what we thought it would be. If we add another pi units to that will be at 25 over 12, which is bigger than 2 pi. And we only want to look on the interval from 0 to 2 pi. So we found the two locations on the interval from 0 to 2 pi where if you plug in this input into this function, the output of that function will be 3, and that 3 is a maximum value. All right, so let's look and see if we can find the two locations where we expect it to have a minimum here of -3. So we know that a minimum occurs on the parent function here at 3 pi over 2. So if we solve this equation, if we replace 2x plus pi over 3 with 3 pi over 2, what will we get here for x? Let's subtract pi over 3 from each side, get a common denominator of 6. So that'll be 9 minus 2, which is 7 pi over 6, and divide by 2, and you have 7 pi over 12. And if your minimum values are a period away, and if the period is pi, if this is 7 pi over 12, then 19 pi, if I add pi to that, 19 pi over 12 is the next time that you're at the minimum value. If you input either one of these values into this function, do this arithmetic, evaluate this function, the output's going to be -3 at those two places. If we add another 12, we'll be bigger than 24 over 12. We'll be outside of the interval from 0 to 2 pi. So we have found our two locations for each of these. So here's the two locations for the maximum value of y equals 3. Here's the two locations for the minimum value of y equals -3. Hey, I hope that helps, and I'll talk to you later.